Today we will be in Chapter 4, Section 1, the Cartesian coordinate system and linear equations of two variables. Our two topic objectives for today are to plot points in the Cartesian coordinate system and to determine whether an ordered pair is a solution to a linear equation. Chapter 4, Section 1, Cartesian coordinate system and linear equations with two variables. Today we're going to be focusing on how to graph all these equations that we've been messing with in chapters 2 and 3. So today we're going to learn how to actually graph these. But first, let's define what a graph is. A graph shows the relationship between two variables in an equation. So that's what a graph is. And specifically, we're going to be talking about the Cartesian coordinate system. And you may or may not have ever seen this depending on when your last math class was, but that looks like this. This is the Cartesian coordinate system. You're going to have your x-axis, which is your horizontal axis, and you have your y-axis, which is your vertical axis. This point here in the center is called the origin. And then we label our quadrants, and we label them 1, 2, 3, and 4. Each one of these sections is called a quadrant, and notice we start with the upper right one, and we start with 1, and then we go counterclockwise. Part of your homework will be identifying which quadrant a point is in, and so this is how this works. So when we're talking about the coordinate system, each point is going to have an x value and a y value. So there are 4 quadrants in the Cartesian coordinate system. There are 2 axes, the x-axis and the y-axis. And then a point is a coordinate, also known as an ordered pair. And you're going to hear it referred to, in our case, more as an ordered pair. And that's going to have an x and a y value. Okay, and then let me show you another picture of the Cartesian coordinate so that you can see the values of our x's and our y's. So this is the x-axis and the y-axis. And the origin here in the center is 0.00. And then if you are in the first quadrant, your x's have a positive value and your y's have a positive value. Because if this is 0 and we move to the right, our numbers are getting bigger. Same thing if we go up, our numbers are going to get bigger. So that means both of our x and our y values are going to be positive. So if we're in the second quadrant, we're going to have negative x's and positive y's. Because we're to the left of the 0, but we're still up on our y's. If we're in the third quadrant, both our x's and our y's will be negative valued. If we're in our fourth quadrant, we'll have positive x's but negative y's. So that hopefully should help with some of that. We're going to do an example, and I'm going to go ahead and just make a Cartesian coordinate system over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6. Okay. Excuse me. There you are. So here's an example. We're going to plot these points. We're going to plot point A, which is going to be 5, 3, B, which will be -3, 1, C, which will be -2, -5, D, not G, excuse me, D, 4, 0, E, which would be 2, 4, and F, let's do 0, -3. A lot of your homework is going to be this, where you're just going to be plotting some points. So we need to learn how to do that. So if we're looking at point A, it says that we need to go 5, 3. Remember that our points are going to be in XY form. So it means we're going to move our X value first and then our Y value. So this one says 5, 3. That means we need to go to the right 1, 2, 3, 4, 5 places, and then it's a +3. So we need to go up 3 places. 1, 2, 3. So right here is point A. Okay, B is we're -3, 1. So it means we have to go to the left 3, 1, 2, 3, and then it's a +1. So we're going to go up 1. And that's B. C is going to be a -2, -5. So we go to the left 2, but then that's a -5, so we need to go down 5, which would put it right here. And that'll be C. D was 4, 0. So that's a +4. So that's 1, 2, 3, 4, but then it's 0, so that means we don't have to go up or down. It's going to be right here on the axis. So that's D. E was 2, 4. So we go 2, and then 1, 2, 3, 4. And that's E. And then F was 0, -3. So 0 is our X value, so we don't go left or right at all. We're just going to have to go up or down. And that's a -3, so we just go down 3. And that'll be our F. So that's how you will plot points when it comes to your graphs. You look at your first value, and that'll tell you left or right. You look at your second value, and that'll tell you up or down. Okay. We're going to go on. Make sure my paper is straight for you. Okay, let's define a linear equation. A linear equation of two variables is an equation that can be put in the form ax plus by equals c, with a, b, and c are real numbers, in this equation, this ax plus by equals c is called standard form. On your homework, it might ask you to put something in standard form, and this is the form that they're wanting. This ax plus by equals c. So here's some examples. These are examples of linear equations of two variables. We have 4x minus 3y equals 12. That's a linear equation of two variables. And notice this is in our ax plus by equals c form. We have ax, And then that's a minus, but we could write that as this, where it's plus and then a negative. So this is still the correct form. This is also an equation, a linear equation with two variables. Even though it's y equals, we could move this over and it would look the same way. We could write this as negative 5x plus y equals 3. So if you can manipulate the equation around to look like ax plus by equals c, then you still have it. The last example is x minus 3y plus 4 equals 0. All of these are examples of linear equations with two variables. Okay, the first type of problems you're going to encounter in this section are going to be either just graphing the point like we did on the last page, or checking that an ordered pair is a solution. So we're going to do some of that. Check an ordered pair is a solution to an equation. Okay, so here's an example. We have the ordered pair 2, 3, and then 4, y equals x plus 1. So we have an ordered pair and we have an equation. And it wants to know if this ordered pair is a solution to that equation. So what you have is we have both an x and a y value, and we just need to plug them in. Remember, our ordered pair is in the form of x, y. So wherever we see an x in this equation, we need to substitute in the 2. And wherever we see a y, we need to substitute in the 3. So that's what we're going to do. So we get 3 equals 2 plus 1. So 3 equals 3. That's a true statement. So this is a solution. Let's do another one. Example. We have x equals negative 3, y equals negative 2, and then we're going to use the same equation for y equals x plus 1. Again, we're just substituting in. I'm going to move my paper up. So when there's a y, we need to put negative 2. Where there's an x, we need to put negative 3. We get negative 2 equals negative 2. That's a true statement. So we're good. Okay. Let's do one more. Example. So the ordered pair 0, 0. And we'll use the same equation for y equals x plus 1. So wherever there's a y, we're going to put in 0. Wherever there's an x, we're going to put in 0. So we get 0 equals 1. That's false. So that's not a solution for that equation. But the first two were. And notice they were both solutions to the same equation. And that's okay. If we wanted to test that, we could plot these points. We'll plot the first two, and we'll have 1, 2, 3, 4. Okay, so the first point we had was 2, 3. So we go 2 and then up 3. The second point that worked was negative 3, negative 2. So negative 3, negative 2. And then those were both solutions to that same equation. So it means we can connect it. And that right there is the line y equals x plus 1. And anything on this line is going to be a solution to that answer. So that means if we went over here to 4 and we went up and found what that hit on this line, we could plug that in and that would work for our equation. So all of our answers for this equation lie on this line. But if there's a point not on that line, it's not a solution. So like our 0, 0 didn't work because notice our line doesn't go through 0, 0. A point out here, if we did 3, negative 3, that point out there wouldn't work because it doesn't lie on that line. So I'll write that down. Any point on the line is a solution. Okay. So that brings us to another definition called collinear. A set of points that are in a straight line are called collinear. So the first 2 points that we had on the last example were collinear. They lied on the same line, so it worked. So here's an example, and this is just like on one of your homework problems. It says determine if the following points are collinear. So we have 0.27, 0, 3, and negative 2, negative 1. So the way you figure out if they're collinear is we're just going to plot them, and we will see if they make a straight line. Unfortunately, for me, I'm doing this just on paper. On your homework, it'll be a lot more accurate, so I do apologize for that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so the first one was 2 and then 7, so we go over 2 and up 7. 0, 3, we don't go over at all, but we go up 3. The next one's negative 2, negative 1. Okay, hopefully you can see that that's pretty close to a line, a straight line. I see I can connect all 3 of these with a straight line. So since I can connect all 3 of them with a straight line, that means these are collinear. All right, let's do another example. And in your homework, it'll be pretty obvious if they're not collinear. 5 over 2. And you do have fractions, and that's okay. We can graph fractions. For 5 over 2, let's think about that as 2.5, because that's what it's going to be. You can simplify that out into a decimal point to make it a little bit easier in order to graph. So let's graph it. And if you want to invest in graph paper, you can, but don't feel obligated to. You can do graphs like this, and then on your homework, I'll show you here in a minute how you do it there, and it's actually really easy. Okay, our first point is 0, 5. So we don't move left or right, but we do move up 5. Our next point is 2.5 and 0. So we're not going to move up or down at all, but we're going to go over there. And then our next point is to the right 5 and down 5. 1, 2, 3, 4, 5. And then down here. Let's see, can we make a straight line out of that? Mine might be a little off, but yep, it looks like we can. We're supposed to be able to on this one. So my graph is a tiny bit off, but these are supposed to be collinear, and if you had an actual graph paper, it would look nicer and these would work. So these are collinear. So obviously we're going to have to do one more example so that you can see ones that aren't. -2, -5, 0, 1, and 6, 8. So let's make our graph. Okay, so -2, -5, we're going to go to the left 2 and then down 5. 1, 2, 3, 4, 5. Right there. The next one is 0, 1, so we don't move left or right at all, we just move up 1. So right now those look pretty collinear. And then the next one is 6, 8. So we're going to go 1, 2, 3, 4, 5, 6, and then all the way up to 8. And if you notice, that one's kind of out there. Like that one you could make a line with this one, but notice our third dot isn't on there anymore. And if we make a line with our first two, then that dot's like all the way over here. So these are not collinear, because you cannot make a straight line with these. So this dot's kind of just way out here in left field. And so, like I said, if they're not collinear, it's going to seem pretty obvious in the process. Okay, after you understand collinear, another way that we're going to be doing these equation problems is going to be determining if an ordered pair satisfies the equation, which is kind of what we were doing at the very beginning, where we were determining if it was a solution. And so here's an example so I can show you what I mean. Example, we're going to determine which of the following ordered pairs satisfy the equation. I'm taking this straight off of your homework. So we would have the equation like 2x plus y equals 4, and then it's going to give us some ordered pairs. We have 2, 0, we have 0, 4, we have 3, 1, and we have -1, -6. So it gives us 4 points and an equation, and it wants to know which of these ordered pairs satisfy the equation. So it's like we were doing at the very beginning of the notes, where we are just plugging in the ordered pairs and seeing if they are true statements or not. So for the 2, 0, we have to plug in 2 for our x value and 0 for our y value. So we have 2 times 2 plus 0 equals 4. If you reduce that down, you get 4 equals 4. That's a true statement. So that means the 2, 0 is a solution. So we're going to do it again for the 0, 4. So we'd have 2 times 0 plus 4 equals 4. So we get 4 equal to 4. That's true. So 0, 4 is a solution. Or that ordered pair satisfies the equation. So let's try the 3, 1. And I keep copying it down just so I can show you what I'm doing. We'd have 2 times 3 plus 1 equals 4. So that would give us 7 equals 4. That's not true. So that 3, 1 isn't a solution. It doesn't satisfy the equation because we got a false statement. Then we have -1, -6 as our last ordered pair. So we have 2 times -1 minus 6 equals 4. Is that correct? Oh, sorry, this is supposed to be a +6. I was like, my notes don't match that. That's a +6. I'm sorry about that. So that'd be +6. Then that works. That's supposed to be 4 equals 4, so that's true. So this is a solution. Okay, so your homework problem will have you do that. It'll have you check, and then it's going to have you graph. It's going to have you graph these points, or at least the 3 that work, So we determined that the 2, 0 worked. So it means we go over 2 and up 0. The 0, 4 worked, which means we don't go up or left or right, but we do go up 4. That one worked. And then the 3, 1 didn't work, but the -1 and then down 6, or excuse me, -1 up 6 did work. So those are our 3 points that we determined did work. And again, my graph is going to be a little off because it's just with regular paper, so I do apologize with that. So that would be our line. Okay, there's one other type of problem that you're going to have on your homework, and I'm going to work one of them on this paper, and then I'm going to actually open up your homework so I can show you. But you're going to be given an equation like y equals 5x minus 6, and then you're going to be given part of an ordered pair. It's going to say 2 comma y, and you need to find out what your y value is. But it gives you your x value right here, because remember our ordered pairs are x, y. So for this equation, anywhere that there's an x, we need to type in a 2. So that'd be y equals 5 times 2 minus 6. So now we just need to simplify this in order to come up with what our y value would be. We'd have y equals, that's 10 minus 6, so y equals 4. So our ordered pair would then be 2, 4. I will work one of these straight off of your homework here in just a moment. Okay. Now, if you get your homework open, I will work a few of the problems with you, mostly just to kind of show you how these problems are going to work and how you kind of graph when it comes to using the Course Compass site. I'm just going to bounce around through them, but I will try and work about one of each of them. So if you're looking at number 1, it says just indicate the quadrant that this point belongs. So then it gives you the point 3, -1. So remember, that's the x value is your 3, and the y value is -1. So we're going to move to the right 3 places, and then the y value is -1, so we're going to move down 1 spot, which puts us in this bottom right-hand quadrant. And, I mean, memorizing the quadrants is just something that you'll need to do for this section. So if you remember, this was 1, 2, 3, and that would be quadrant 4. So you're just going to pick the quadrant that says 4, and then check your answer, and you got it right. So that's going to be some of your homework. It's just indicating the quadrant. Okay. Number 3, sorry about that. Number 3 talks about you're just going to go over to the ordered pair and then you type in the value. If you look right here, this magnifying glass will make the graph bigger for you, so you don't have to strain your eyes. And there's normal, medium, and maximum, so you can make the graph actually really big. So if you're having trouble seeing the graph, just click that little magnifying glass and then you can make it bigger. I'm not going to work this problem because hopefully you can count over and count down. Just remember that your x value goes first, and that's your horizontal value. Alright, I do want to do number 4 with you just so that I can show you how to graph on the Course Compass site. This one we're going to graph these points, and we can graph them right here, but it's easier if you can graph them on the bigger one, so I made the graph a little bit bigger. And the first plot, or excuse me, the first point we are plotting is A, which is -5, -4. So we're going to go to the left, -5, and notice how we have that dashed line now, so it kind of helps you to make sure you're staying straight. And then we have to go down 4. And then once you get there, you can plot that point, click save, so it'd be -5, -4, and we can check our answer. Good job. Alright, now we have to plot B. B is -1, 0. So it means we go to the left, -1 spots, and then we don't have to go up or down. So we check our answer. Good job. Alright, we're going to keep going. C is -2, and then positive 1. Check our answer. Good job. And then D is 0, 2, so we're not going to go left or right at all. We're just going to go up 2 and put the point in there. Check answer. Good job. E is 5, 3. So that means we go to the right 5 and then up 3. Good job. And then last but not least is F, which is negative 3 and then negative 9 over 2. And it would probably help you to simplify this into a mixed number so you know where you're going. 9 over 2 is going to simplify down to 4 and 1/2. And so that means we have to go down 4 and 1/2. But let's plot our first one, or let's go to the left, negative 3, because you have to do your x value first. And then the negative 9 1/2 is negative 4 1/2, so we have to go down. And notice as we go down, like we're able to do halves. Like there's negative 4, but we're able to go down just a half spot. So if you have to graph with halves or any type of decimals like that, it will allow you to do that. Your graph will be set up so that you can do that automatically. So let's save that. Let's check our answer. Good job. So that's how you're going to use the graphing on this. And that's graphing, but then determining if they're collinear. This is exactly, if you look, this is the exact same equation that I used in your notes. And then it's just determining which of the 4 ordered pairs satisfy this equation, and then you would plot it. I'm not going to do that one. Again, same thing. Okay. I will do number 10 with you. Number 10 is a lot like the last example problem that I gave you, only this time it tells you what your y value is, but not with what your x value is. So, let me pull up my paper. So it says, consider the linear equation of 3x plus 2y equals 7. Find the value of x that makes this given ordered pair a solution. So we have x comma 2. Remember, ordered pairs are x, y values. So it means we know our y equals 2. So anywhere in our equation that there's a y, we need to put in a 2. So we have 3x plus 2 times 2 equals 7. So I'm going to simplify. And then I'm just going to solve for my x. So that means I have to subtract the 4. So I have 3x equals 3. Divide both sides by 3. So I get x equals 1. So my ordered pair would be 1, 2. So here it just says x equals, and we determined x equaled 1. So we're going to put in 1, check our answer, and that's correct. Hopefully this isn't too difficult. Remember, there is this nice little button over here that has helped me solve this if you do get stuck. And if you want extra practice doing the same problem more than once, hit the similar exercise button so it'll regenerate you another problem. Good luck on your homework and good luck on your quizzes.